So we've learned how to find the derivative of a function by first principles, but I'm sure you will agree with me that first principles is quite a long and tedious process. So something that you don't really want to have to do unless you're being told to do that. So please watch out that unless it actually says by first principles, there's another option. You can use a much shorter way of doing it, and this would be what we're calling our rules of differentiation, okay? So these rules are helping you find the derivative of a function without needing to go through that whole first principles process. So now there's a couple of rules that you need to know for this that are going to be handy and are going to help us understand how to find the derivative. First rule basically is this: if I've got a function of f of x where the coefficient, the value in front of your x, is k and it's x to the power of n, okay, this is what the rule says. We need to take the exponent and we need to multiply it by the coefficient. So to find the derivative, well, let me write it over here. To find the derivative, which is f prime x, it's equal to k times by n multiplied by your x, and then what happens is we always subtract 1 from your exponent, okay? So you take the exponent, you multiply it by the number in front, and you subtract 1 from the exponent. So if, for example, if I had 3x to the 4 as my f of x function, and I said find the derivative of it, all right, well, the rule says that I have to take 4, I need to multiply it by the coefficient, 3 times 4 is 12, and I have to subtract 1 from my exponent, leaving me with 12x to the 3. There we go. That's what you have to do with that rule, okay? If you have got a function that looks like this, and basically the only difference between rule 1 and rule 2 is that I've still got a coefficient of k, I've still got x, but there's no exponent sitting above x over there. Do you see that? Technically, there is an exponent, we just don't see it, and the exponent is a little invisible, 1, okay? So if I did apply rule 1 says take the exponent and multiply it by the coefficient. So if we do that, then k times by 1 is just k, and I would have x to the, now the exponent is 1, and if I subtract 1 from it, 1 minus 1 gives us what? Obviously 0. And anything to the power of 0, remember, anything to the power of 0, rules of exponents, is just 1. So k times 1 is just k. So what is that all saying? If you've got a term where you've got something like 2x, where x doesn't have an exponent above it, the derivative of that will be just 2. So it's just whatever the number is, the coefficient in front of it. So if, let's say, I've got f of x is 7x as an example, the derivative of that, because the exponent over there is a little invisible, 1, it means that through this whole process over here, the x to the 0 cancelled and we were just left with 7. Okay, so that's the second rule. Just if you've just got an x, basically the x falls away and you're left with just the number in front of it. Then rule 3 is if I've got the coefficient of k, but there's no x, okay? So in other words, k is what you call a constant term, all right? Now what happens to that if I'm finding the derivative, but there is no x, okay? Well, let's look at it like this. I'm going to say that, or let's actually, no, we need to take away that for now. So just f of x equals k. Now, if I did put an x behind it, it would have to be to the power of 0, because remember, anything to the power of 0 is 1, okay? So if I did that and I went back to applying law 1, anything multiplied by 0 is just 0, and in fact, that's it, okay? It would just end up being 0. So what's the rule? If you've got a constant term, okay, anything that doesn't have an x in it, when you're working out the derivative, constant terms just fall away. Okay, x, there's no x there, so therefore it's not going to exist. Okay, so those are your first 3 laws. I'm going to give you a nice example here. Let's say I'm going to just throw everything together. So f of x equals 2x to the 5 minus 3x squared minus 4x plus 6, let's say. Okay, what's my derivative going to be? All right, law 1 says 2 times 5 is 10x, and I subtract 1 from there, so it's 10x to the 4. 3 times 2 is 6x to the 1. Okay, here x is just on its own. So remember, law 2 said that if it's just an x, the x falls away and you're left with just the coefficient. And here we've got a constant term. So that's law 3, which says if there's a constant term, it falls away. Okay, so there we go. That then is the derivative of that f of x function. Okay, we're not done, unfortunately. There's 1 or 2 more things you need to make sure you know. When we're applying the rules of differentiation, there's two those like by the way things that you have to know and you have to make sure that you apply, otherwise you're not going to get them right. Okay, the first one is basically this. If you're finding a derivative in terms of x and you ever find any variables of x in the denominator of a fraction, the rule is you may not apply the rules of differentiation if the variables that you are finding the derivative in terms of is in the denominator. So you have to go right back to laws of exponents here. And laws of exponents say, well, that's actually okay. I can bring this up to the top as long as I then make it a negative n. And if I do that, then x is up in the numerator and then it's all fine, which is exactly what you need to do, okay? So if I have a function, let's say of y equals, let's put a little y equals here, 2 over 3x squared, and we need to find its derivative, okay? I'm just going to use the notation of f prime x because we haven't spoken about any notation yet. Before we can even write the derivative, we need to make sure we bring that up to the top. So this is going to come up to the top. It's going to become 2x to the negative 2, and it stays over 3. Do you see that only the x squared came up to the top? The 3 wasn't a problem. Okay, that wasn't the variable part. So the 3 stayed where it was. Now we could apply the rules of differentiation, giving us just a negative 4 x to the, now if I subtract 1 from negative 2, that's going to land up giving you negative 3 over 3. And we'll get more involved with this later, but what I would then do is bring 3 back down, the x to the 3 back down to the bottom to make it positive again. But we'll do more of those in a minute. The other problem is if you ever have a surd, okay, a root sign, okay? You can't apply rules of differentiation if your term is a surd. So you need to change it to exponential form, all right? And if you recall rules of exponents, this a over here, if I'm finding the nth root of, okay, this a I'm going to keep as the nth root of because that essentially is a coefficient part of it. But the exponent over here, remember your rule is that if you have got an exponent and you are finding a root of it, you divide your exponent by the root. Okay, so it would be x to the m over n. All right, so as a very basic example over here, the root of 9, okay, well that's easy, that's 3, and then for x, well, the exponent above your x is a 1, and if you don't see it, remember you're finding the square root, so that would then be x to the 1 over 2, all right? Then we could, once we've done that, then we can go back to the rules of differentiation, which we're going to practice a bit later, so let's leave it at that for now. Okay, and then finally, just to talk about symbols of derivatives. Calculus is just one of those sections where they're quite sticky in terms of the way you write stuff, so you want to just be quite particular with that, okay? So very quickly, if you have been given a function as f of x equals, all right, it's important that you understand that the derivative notation, if your original function is f of x, is f prime x. And that would apply if it was p of x, then your derivative would be p prime x, or g of x would be g prime x. So that's your notation for derivative if it starts off with just an original f of x. If your original function starts with y equals, okay, because sometimes it does, the notation, if you start with y equals, can you see we're finding the derivative of y and it's going to be in terms of x. That's the variable, okay? So therefore the notation for the derivative we say is dy, derivative of y in terms of x. So dy over dx is that notation, all right? And then the next one you're going to see is where you see dx, and you'll always have square brackets and your function inside the square brackets. That dx is saying the derivative in terms of x of 3x, x to the 6 is, all right? And basically, if you have that notation over there, once you have found the derivative, we just simply say equals, because this over here is saying the derivative in terms of x of that function. So the point is, once you've found the derivative, it is just equal to that. Okay, so I just want you to be aware those are the different types of notations of derivatives. Okay, you'll see them a lot, so hopefully become really familiar with it. And then, yeah, that's your rules of differentiation. So I think at this stage, you want to go back and just have a look at them, make sure you are understanding those, because I'm going to take quite a fair bit of time now to go over each one of them and really practice rules of differentiation. So I will see you in the next video.